Hello, everyone. Welcome back. Today, we're going to learn about circles and ellipses. So our goal is basically to define each and then understand how circles and ellipses are related to conic sections, the relationship between circles and ellipses themselves, and then also be able to find the center and radius of a circle, I should say also a circle or an ellipse. Well, leave it. Let me put this, actually, let me correct this, be able to find the details of a circle or ellipse. And by details, I mean basically things like center, radius, was also called some vertices of ellipses, also called foci of ellipses. We'll talk about those, and also be find the equation of ellipse or circle. So first off, let's review a conic section. So a conic section is something that's created when a plane, it says plane intersects a right circular cone with two parts. So imagine we have a cone, basically two cones, and it's called right cones, basically meaning that I think the line that goes right down through the middle of each cone, that's called the axis. Basically, it's at a right angle to the bottom of the cone. Okay, and so that's why it's called a right circular cone with these two cones pointing toward each other. Now, if you take a plane, like a section of a plane, think like a piece of paper, and cut down across that, depending on where you cut, you get different kinds of what are these called conic sections. Okay, now the most basic ones, or if you cut it parallel straight across, you get a circle wherever you cut it. But if you cut it at an angle, then as soon as you get a feature that's not circular, but it's called an ellipse. As we'll see, actually an ellipse is a type of circle. And also if you cut it in a way that cuts through the open end, you get a parabola. And if you cut it basically in a way that's perpendicular or along the line of the axis, you get what's called a hyperbola. So today we're going to focus on or discuss circles and ellipses. So an equation, first let's talk about circles. And the circles you're most familiar with, of course. But you may or may not have seen the general equation that often. Okay, so the equation of a circle in general is with the center of what's called HK, and these are the coordinates of the circle, and the radius is R, where R has got to be positive, is given by this. Okay, that's the most general form of the equation of a circle. It's also called the standard form. Okay, now if you have a circle that's centered at the origin where H and K are both 0, it just reduces to this. Okay, and that's also related to the Pythagorean theorem, and that's not a coincidence. And here's just a basic picture of what that would look like. So the circle is essentially the set of all the points that are the same distance from the center point. And that's what a circle means. Okay, let's take a brief look at a few examples with circles. So let's take a look at number one. Let's say we have an equation. X minus 2 squared plus y plus 3 squared, that's a 3, is equal to 4. Okay, now then we need to figure out what this is, what this means. All right, we find our center and our radius. So our center, also what you do between the center and the radius is you actually switch signs. So if this is negative here, it becomes positive here. So the x coordinate of our center is positive 2. And here it switches signs as well. This is positive 3, so the y coordinate of the center becomes negative 3. And then the radius is essentially the square root of this part. Okay, so our radius then is the square root of 4, which is equal to 2. Now, if we go to Desmos, we can graph that pretty easily. You can actually graph circles, the equations, just they're written. Let's do that. So if we have x minus 2 squared plus y, I need parentheses, so y plus 3 squared equals 4. So that's our circle. So as the center, and once again, as we said, it's positive 2, negative 3, has a radius then of 2. Okay. Now, what if we said we want to find, for number 2, let's say we want to find the equation of the circle with a center. So this time we're going backwards, given the center and the radius. So our center, let's say, is going to be -3, 0. Okay. And the radius is equal to 3. Okay. So plug it into this. All right. And so we're going to have is basically x. Now the formula, oops, I need the x on the inside of the parentheses. So I have x plus or minus something squared. So it's mean minus is part of the formula. But then what I'm subtracting itself is negative. So it's -3. Okay, and that's squared. Then plus. Then we have y -0 squared, then equal to 3 squared. Okay, now let's pull this together. So now, if we simplify this, of course, a minus subtracting a negative gives us a positive. And so we get x plus 3. That's the reason the signs change. Okay, and plus this case, we can leave it as y minus 0. So best just put it as y squared is equal to 3 squared, which is 9. Okay, let's graph that, make sure that works on Desmos. And so let's actually turn this one off. And so we have x plus 3 quantity squared plus y squared is equal to 9. Okay, that's our circle. So our center then is the point 3, 0. It has a radius of 3 if you count up. So 2, 1, 2, and 3. Okay, so that's the equation of our circle. So this is hopefully very familiar to everyone because we're pretty familiar with circles, which just kind of gives you a basic idea of how the general equations work. Now let's take a look at something a bit different. What we're going to do now then is actually find the equation of the circle, okay, in standard form. Now, this is not the only way you can write out the equation. So what you imagine if we took, like, either one of these equations, okay, imagine if we, of course, took this, and for example, x minus 2 squared means x minus 2 times x minus 2. This would be y plus 3 times y plus 3. If we multiply those out, FOIL them out, and simplify our terms, we get something very different, which would still be the equation of a circle, but it wouldn't be as useful a form, okay? But that can still be the equation of a circle. Let's take a look at what I mean, and we'll say how we can go from a different form to a form that's easier to work with, better to work with. So let's say we have x squared plus y squared plus 10x minus 12y is equal to 3. Okay. Now, believe it or not, this actually is the equation of a circle, and we can actually do that once again by plugging it into Desmos and seeing it. Let's do that. Let's turn these off. Okay, let's just type that in. X squared plus y squared, and then plus 10x minus 12y is equal to 3. And we'll see, well, if there's a circle, although you can see it's a little large, okay, that is a circle. Now, that's not, as I said, that's not the best form of the circle because it's harder to tell exactly where the center is and also what the radius is. So let's actually put it in standard form. It's easier to work with. And we'll see it gives us the same thing. Okay, the way we're going to do that is a few steps. So first, make sure that our constant term is, if there's a constant term here, is on this side, on the right. Okay, and what we're going to do is complete the square. In both x and y. Okay, so what we're going to do, all right, so what we're going to do then is put our x terms together, x squared minus 10x. Then we have to add something and subtract something, and then do the same thing with our y terms, y squared minus 12y. We have to add something and then subtract something, and then we still have our 3 over here. Okay. Now, and what we want after we do this, our goal then is make it look like the standard form, x plus or minus something squared plus y plus or minus something squared is equal to some number over here, which won't be, most likely won't still be 3, be something else. Now, so once again, this is why it's called completing the square, because we want to have these squared terms. Okay, so what we're going to do then is we're going to take half of this, take the number in front of our x, take half of it and square it. but including the sign. So half of it is -5 squared. And that's what we add and subtract, -5 squared. That's also what we put right here. Okay. And over here with the y's, once again, same thing. We take half of this and square it, which is -6 squared. Okay. And that's also what goes right here. Okay. So now basically then we have to figure out what's on this side. All right. So do that again. Make sure you have plenty of space. So minus 10x. And so obviously this can be plus 25 minus 25 and plus y squared minus 12y plus 36 minus 36 is equal to 3. That's going to be the reason why we're adding subtracting it. So we can't change. If we just simply add it to one side, then basically we're changing what the whole thing means. Okay. So now we're going to essentially kind of group these. Those will become our perfect square terms. Then we're going to add 25 and then 36 to both sides. Okay. And so now if we factor this, we find out this is x minus 5 times x minus 5 plus, and if we factor this, we'd find it's y minus 6 times y minus 6 . Okay, and that's equal if we add all these up. So 3 plus 25 is 28. And plus 36, I believe, should be 64. Double check that. Anyway, so this going to be 28 plus 64. Okay, and now if you realize that x minus 5 times x minus 5 is x minus 5 squared, y minus 6 times y minus 6 is y minus 6 squared, and this side is 64, then that's the equation. That's actually the same equation. And here we easily see our center is 5 and oops, I'm sorry, just hang on. I think I realized I just, oops, I did. That should be a plus. I'm sorry, it'd be plus 10, which is an easy fix. These also be pluses on the 5 side. I'm sorry about that. Should have been more careful. Okay, there we go. So this then is -5 for our x coordinate, positive 6 for our y coordinate of our center. Then the radius is the square root of this, 64, which turns out to be a perfect square. It isn't always. That's going to be 8. Okay, let's take a look at that. Let's graph that, see if that's the same thing. So x plus 5 quantity squared plus y minus 6 quantity squared is equal to 64. Yeah, see, it's exactly the same thing. Okay, that's just another way of writing that equation. This is usually a better form because we can understand more about the circle from this form than we can from this form. There's nothing wrong with this form. Okay. All right, let's do one more of those really quickly, and then we'll talk about ellipses. Let's start on the second page. Number 2, how about we have this time, let's say we have x squared plus y squared minus 6y plus 7 is equal to 0. Okay. Now, similar way. So first thing, we want to put our constant on the other side. So subtract 7 from both sides. And also let's go ahead and group our x's and y terms. So we're going to have x squared. Okay. And then we're also going to have plus y squared minus 6y. And of course, if we, actually, let's make this a -7 instead. Okay. So add 7 to both sides. This is 7. Okay. Now, you notice this one, there's no other x term that's only have x squared. So in this case, there's no reason to do anything else with the x. It's already done in a sense. Okay. But this one, at the same time, you also need to complete the square here. So I need to add something and subtract something. So I need to complete the square just only in y this time. Since I have no other x terms, nothing else to do. So what I want to get out of this is going to be just x squared, and then plus y plus or minus something squared is equal to some number on this side. Okay, so let's do the same thing. So once again, take half of this, which is going to be -3, and that's what I square, what I add and take away. Okay, and then that's what I put right here is -3. And then we have x squared plus y squared minus 6y plus 9, then minus 9 equals 7. So we want to group, since you group these terms, and then add 9 to both sides. Okay, and so we're going to have x squared. And this then, if we factor this, this would be y. Oops, it's going to be y minus 3 and y minus 3. You can check that on your own if you like. And this side is going to be, it's going to be 16. It didn't, so that will actually come out and be a perfect square as well. Okay, then of course, y minus 3 times y minus 3 is y minus 3 squared, and this then is going to be 16. And so that then is the same equation as this. So once again, this one you can try on your own. So basically, if you graph both of these, you'll get the same thing. And you can also find your center and your radius in the same way. Okay, so that's our basic discussion of circles. So now we're going to talk about next, or talk about ellipses. Okay, so ellipses, it turns out a circle is actually a type. Sorry about that. That was strange. Okay, let's talk about ellipses. Okay, so let's move down to the next page over here and talk about what an ellipse is. Okay, now ellipse is imagine we take a circle and stretch it out. We either stretch it vertically or horizontally. Okay, this one's stretched vertically, this one's stretched horizontally. And what we'll see is that basically a circle is essentially a type of ellipse. So let's explain that. So this one's kind of a general equation of an ellipse with a center at h and k, like we have with the circle. Okay, but it has a few more features. So basically, what happens is basically the coefficients or numbers along with the x and y. With a circle, those are the same. Okay, your coefficients in front of, and for a circle, x and y are the same. Okay, which means you can always divide through and basically get them to be 1. Okay, but here, that's not the case. Here we see these a squared and b squared, those are different. Okay, and so if they're the same, we can just multiply through, divide through by them and get, basically have a circle. But since these numbers in front of the x squareds and y squared terms are different, then we have an ellipse. And basically, if here we're looking at a squared as being the bigger number, if that's the case, if a squared is beneath the x, the bigger number is between the x, that means we have this ellipse like this with a horizontal, it's called the horizontal major axis. So the major axis goes from end to end. So it's the longest axis, goes from end to end. Okay, and then the minor axis goes this way. Let's draw a couple pictures over here, fill in a few more of these details. This is actually taken out of a textbook. So if we have an ellipse like this, so this is the major axis. And this is the minor axis. In this case, okay, looks like this. Okay, so the major axis, the long axis, this is with a horizontal, basically a horizontal major axis. In this case, is a squared is under, let's say, the x term. Okay, it looks like that. Then, but if it looks like this, okay, well, this time our major axis is this one. The major axis, abbreviate that. The minor axis runs horizontally. Okay, and this is a vertical major axis. Okay, and in this case, so the a squared is under the y term. And basically what that means is, so if the bigger number is under the x term, you have a horizontal major axis like this. And then if it's not, then it's under the instead of the y term, we have a vertical axis like this. Okay, it's turned this way. The long axis goes up and down. Okay. But essentially that the equation is basically identical. Now, a few more things they have. So these points right here, then, are called vertices, or have a vertex. Okay, these points right here, those are what are called the vertex or vertices. Okay, at the ends of the major axis, the end of the long axis. Okay, and basically this major axis has a length of 2a, 2 times a, this number right here, and the minor axis has a length or distance of 2b. Okay, this number right here. All right. Now, a couple other things they have there are what are called foci. Right here and right here. Or I should probably say focus. Since I'm pointing at one at a time, but they're plural, they're called foci. So like a parabola is a focus. This also is a focus. So this is a focus. And this is also a focus right here. Okay. And those are also important points of a parabola or of an ellipse. All right. So, and basically, as you see, this gives us the equations or relationships of these. All right. So let's take a look. What we're going to do then is take a look at a couple of few examples, practicing with this, kind of getting a feel for this, how this works. So let's do that. Let's move down and take our first example. Okay, let's do a basic one. So number one, we have x squared plus x squared over 25 plus y squared over 36 is equal to 1. Okay, now, so I want to make it kind of look like these equations. Okay, either this one or this one. All right, so let's basically write each one of these denominators as something squared. And so that's going to be x squared over, whereas 25 is 5 squared. Now, they won't always be perfect squares. In this case, they are. It's a simple one to start with. Whereas 36 is 6 squared is equal to 1. Okay, so let's pick out a few things we have. I'll just over here say, so a, or a is the biggest number here. This looks like this one. Okay, so a is 6, b is 5. Okay, so this is a vertical major axis. Okay, now what else we know? Well, actually, we can see that since we don't have x or y minus anything, actually the center of this one is just 0, 0, the origin, which is nice. Okay, so like a circle, anytime there's nothing, subtracted or added in the x terms, that means that coordinate, the center of that, or that coordinate center is 0, 0, 0. Okay, now a few more things. So our major, what's called our major axis, which is vertical, is length is 2 times a, or 2 times 6, which is 12. And then the minor axis length is equal to 2 times b, which is 5, which is 10. Okay. I also want to find our foci. All right. So let's we're looking at this one. So our foci is going to be, we define what's called c. Okay. So we have a little equation in both cases. So c squared is equal to a squared minus b squared. And so c squared is going to be, I already have a squared is 36 minus b squared, which is 25. And so that's going to be, that can be 11. And then c, of course, and c is going to be square root of 11, which of course doesn't come out evenly, but it's going to be 11. Okay. So our foci going to have two of them. All right. And it says one is going to be h, the x coordinate of our vertex, which is 0. And then k, the y coordinate of our vertex, which is also 0. Okay. Plus c, that's going to be 0 and the square root of 11. And then the other one, similarly, is going to be h, which is 0. And then k minus c. So k is 0, minus c is negative square root of 11. Okay. So finally, let's draw this. So our center here is 0, 0. Okay. Now, also our vertices, okay, h and k. So h and k are both 0 plus a. Basically, our major axis has a length of 12. So this basically goes from 0, 6 to 0, negative 6. The length of 12 is centered 0, 0. Okay. And then our minor axis has a length of 10. So it goes from 5, 0 to 0 or negative 5 and 0. Okay. Then our foci are going to be somewhere here. So it's 0 and square root of 11. And so here is 0 and negative square root of 11. And so our ellipse looks something like this. Now, we'll also do this on Desmos. It looks something like that. Okay. Now, let's verify that with Desmos. Also, I guess I could have also added here. So h is equal to 0 and k is equal to 0. All right. Now, let's graph this with Desmos and see what we get and see that it looks exactly the same. Okay, let's turn this off. All right. So turn this one off as well. So x squared divided by 25 plus y squared divided by 36 is equal to 1. Okay. Now let's see. So we said we should have, our vertices should be at 0, negative 6 and 0 and 6, right? The length of our major axis is 12. Then these points here, the length of our minor axis is 10. So these points are going to be at 5, 0, and negative 5, 0. Our center is at 0, 0. And we're going to do the square root of 11. So QRT of 11 is approximately 3.31. So that's about where our foci are going to be. Okay. About right in here. We don't show them on my lab, but basically if you could actually plot the points if you wanted to. So that gives you an idea that is correct. Okay. So we found the correct values of our ellipse. Okay, I guess I can fill in a few more details. So this is a vertex here, the ends of our major axes. Okay, let's do another one. And this time, let's do one where it's not already kind of given in the form exactly like this. So give me just a moment to find the one I want to do. Okay, look at this one, number 2. So let's say we have this. We have 4 times x minus 5 squared plus 3 times y minus 4 squared is equal to 48. Okay. Now, you see that that's obviously not in the form of either one of these. In fact, we're not even sure which case it is, whether it's a long axis or short axis yet. To figure that out. Okay. So I want to write I'll say write in, I'll say standard form. And basically make it look like one of these equations over here. How we do that then is we're going to divide both sides by 48. Okay. So essentially, we're going to divide everything by 48. Right, dividing both sides by 48. Now, if you notice 4 over 48, that's going to be x minus 5 over 12. This is going to be um, y minus 4 squared over 16. And then, of course, 48 over 48 is 1. Okay. Now, we get a little bit closer. So now, actually, let's also write this as x minus 5 squared. Both is something squared, so that's the square root of 12 squared. And this, of course, is y minus 4 squared over 16, of course, is 4 squared is equal to 1. Okay. So now this time, this looks much more like what we had before. Okay. Um, hmm, I just realized, though, this one's going to be another one with a vertical axis. So actually, let me do something. Let me actually switch these. Let me actually, all right, let me just switch these numbers. Make this one 3, make this one 4, because I want to do one with a horizontal axis. Okay. All right. So now this time 3 over 48, this is going to be 16. This one is going to be 12. And so once again, this is going to be, of course, 16 is 4 squared. This is the square root of 12 squared. Okay. Now, let's write down what we have. Okay. Since now, let's just be a plus as well. It looks like, so basically, it looks like one of these. Okay. In fact, since 16 is larger than 12, we know this can be a horizontal axis. So let's write down a few things. So H, the center, is equal to H and K. It's equal to, and also this is the same thing happens as what happened with the circle happened with here. So basically switch the sign. So if these are minus here, they're plus here. So the center is going to be 5, 4. Okay, that's H and K. All right. Now our A then, the bigger number A is going to be 4. B is going to be the square root of 12. Okay. Now, so this time we have a horizontal major axis. Okay. So our vertices, okay, are going to be, we have 2 vertices, and they're going to be basically plus or minus B. Okay. Well, not quite. So one vertex is going to be this H minus A and K. Okay. So H is going to be 5 minus A, which is 4, and K, which is 4. And that's going to be 1 and 4. Okay. Right here. So H minus K, or H minus A and 4. Okay. The other vertices, vertex, will be H plus A and K. That's going to be 5 plus 4 and 4. And that's going to be 9 and 4. Okay. Now, the major axis is going to have a length of 2 times A, or 2 times 4, going to be 8. The minor axis has a length of 2 times B, which is 2 times the square root of 12. And that's going to be just 2 times the square root of 12. Let's approximate that. And I'll just use Desmos. So I have my calculator with me handy. So 2 times the square root of 12 is approximately 6.98. Okay, about 6.9, 6.93. That's the approximate length of our minor axis. Okay. Now, let's also need to find our foci. So c squared is equal to a squared minus b squared. And that's equal to, we know what a squared and b squared are. They're these numbers right here. That's going to be 16 minus 12. And that's going to be 4. So that gives us that c is equal just to 2, which is nice. Okay. So our foci All right, we have two foci, two focus here and here. This is H minus C, okay, and K. Remember, H was 5. So 5 minus 2 and K, which is 4. And that's going to be 3 and 4. And then the other one is going to be H plus C and K. So 5 plus 2 and 4, which of course is going to be 7 and 4. So it's a little tedious writing all this out, but now that we know everything we need, let's draw this. Okay. So here are our axes. All right. So 5 and 4, 0.54, let's say it's about right here. That's our center. Okay. Now, our vertices, 1 and 4 and 9 and 4. Well, actually, let me move that down out of the way. So 1 and 4 and 9 and 4. Okay. Now our foci are going to be 3 and 4 and 7 and 4. Okay. Now other points actually probably should approximate the square root of um, 12. So we'll just simply the square root of 12 is what? So the square root of 12, let me just delete this. So about 3.46. Okay. And that's going to be, so in this 5, and basically plus or minus 3.46. So that's going to be about 5 and 7.46. And down here, that's going to be 5 and 5 minus 3.46. So 5, just do 5 minus the square root of 12, about 1.53, 1.54. So about 5, 1.54, 1.54. Okay. All right. So now this is going to look like this. So it's a fair amount of information, but we can find all of that. And now let's graph it and make sure that's correct. Okay. All right. So let's make sure all these rest of them are turned off. All right. Now let's graph the original version. So 3, although it doesn't matter, times x minus 5 quantity squared plus 4 times y minus 4 quantity squared is equal to 48. Okay. Now let's take a look at some of those. All right. Yeah. 5. Something maybe 1 and 4. I'll make sure that's correct, but 1 and 4. Oops, I realized, yeah, 9 and 4. Good. I was actually made a mistake on these. I apologize for that. I subtracted them from 5, should have been from 4. So let's go back and fix that. Yeah, so should have been 4. So basically that should have been 4 minus the square root of 12, not 5. Let me fix that then. And that will match that. 4. Yeah, 0.535. Yeah, exactly. Okay. So let me go back and fix that here. And some of this gets a little tedious sometimes. Nope. 5 and what did I say? So 0.5, 0.53. All right, so if I draw it again, try and do this again. Okay, not a very good ellipse on paper, but you get the idea. So we graph that, and once again, so that matches everything. Okay, so then we have our vertices. Yeah, so that's our ellipse. Okay, and then the foci, once again, we got those. So basically, from those equations, you can find all your foci, your ellipses, your minor axes, and so forth. Okay, and also you convert that then into kind of more what we call a more standard form, like you see. All right, let's take a look then. Now, also here, let's also be able to go the other way. And what I mean by going the other way is, let's take a look at another example or two. This time, what we want to do is, this time, let's say we're given information instead of being given the equation, we're given information about it and want to be able to find the equation. Find the equation of the ellipse. All right. Let's say what we're given is we know our vertices, okay, are 0, -6, and 0, 6, okay? And the foci are at 0, -4, and 0, 4, okay? So it might not draw kind of like a basic picture, at least what we have so far, right? Then we draw a straight line. Okay, so what we have, so 0, 0, 6, 0, -6, and then our foci is 0, -4, and 0, 4. So hopefully what you can see here, from this, we can tell that we have a vertical major axis. We're not really sure yet how wide it is. A vertical major axis, and it's on the axis itself. What that also tells us then is our center is 0, 0. Okay, we see that in a couple different ways. Let's take a look down here at the equation with the vertical major axis. So here we know our, if those are our vertices, the x-coordinate of vertices is h, right? So h has got to be 0. Okay, and then basically, if that's going to happen, then, and also if you notice our um, vertices are always, and both ends of our major axis, it's the middle point, then is going to be 0. Okay, good. So know a few things about this one. That's the center. All right. Now, so also what we know is that's the center. So we can figure out what A is. Okay. A is going to be, if you look at our vertices, this equation is going to be K plus A. So actually, I should probably say a few more things before we get to A. So let's say this, we know that H is equal to 0, K is equal to 0. This implies then that A, okay, if our vertices are H, the x coordinate is H, which is 0, and this is either K plus A or K minus A. We said that K was 0 since we're at this, our centers at the origin, and A is going to be equal to 6. Okay, good. We're getting closer. But now we still need to know what B is. Okay, so remember, I should have said this before. What we want out of this. Sorry, I should have put this up before. So what we want is x squared over, in this case, b squared plus y squared over a squared is equal to 1. Since we know this time we have a vertical major axis, a squared is under the y squared term. Okay, so we need to find b. How do we find b? Well, we're going to use this relationship we have with c, a, and b. So c squared is equal to a squared minus b squared. Okay, we're going to use that. In this case, we just essentially solve this for b squared. And so, what's the best way to do that? So, if we subtract a squared on both sides, we're going to have a negative b squared. I'm turning this around. It's going to be c squared minus a squared. Now, divide everything by -1. Remember, divide both sides by -1. It changes all your signs. That makes this nicer. So b squared is equal to, and that's basically going to make this a squared minus c squared. Because this is going to change this sign here. Okay. This one signs become negative, this will be positive. Okay. Now, we can do that. We know both A and C. So let's go down here. Where B squared is equal to an A squared. We said that A also didn't say what C was. We get C from our foci, okay? So the equations for the foci, okay, once again, our H is 0. Then if K is 0, then it's either plus C and minus C. So that means that C is equal to 4, okay? Now, so B squared is equal to A squared, which is 6 squared minus 4 squared. And that's going to be 36 minus 16. And that's going to be 20, okay? And that's B squared is equal to 20. Now, if you want to know B is going to be the square root of 20, let's simplify. But actually, we really need to know is B squared, okay? Well, I said find B. I probably should have simply said find B squared. That's what we really need, okay, for our equation, okay? So our equation is going to be x squared over B squared, which is the square root of 20 squared. B squared is 20, plus y squared over the square root of 6 squared, okay, that's 1. And then if you just want to multiply everything through, so you have, or multiply everything, so you have x squared over 20 plus y squared over 36 is equal to 1. Okay, all right, so with that information, then we can actually go backwards then and find out what our equation is if we know those information, okay? And other things you'd be given, okay? For example, if you're given, we say a few more things about this as well. So you know our major axis, a little bit more information, is going to be 2 times 6, which is length of 12. And you can see that then from positive 6 to negative 6. Then the minor axis is going to be 2 times the square root of 20, which is going to be 2 times the square root of 20, which you can approximate if you want. Okay. Now, one more thing. Let's graph this one and make sure that looks correct. Let's go back to Desmos. And so we have x squared divided by 20 plus y squared divided by 36, and then that's equal to 1. Okay, all right. So those are at 6, and then actually, if you check this, these points right here, okay, let's try to have a little issue with that. But basically, those points, that should be then the square root of 20. So do the square root of 20. Okay, about 4.47. And that was about 4.47. Well, let's just do it this way. So I actually label a point. So square root of 20 and 0. All right, that's that point. If we do negative square root of 20 and 0, we get this point right there. Okay, good. That's correct. So that is our ellipse. I guess I can go ahead and do that. So label some of the rest of the points. And so if I do negative square root of 20 and 0, oops, give up another radical first, 0. Okay, that's that point. Okay, let's label both. Okay. And then, of course, I guess we can also go ahead and label our vertices. So 0 and 6. 0 and negative 6. Label that. Okay. We can also label our foci. And so that's going to be 0 and 4. And the last one then is 0 and negative 4. Okay. And that's basically everything we need to know about that ellipse. Okay. All right. So that fits everything we've seen. Okay. Now, a couple more things I want to mention about ellipses and about all of this. So actually, I need to probably just need to go through. In fact, I may just need to start a new one of these. Let me just start a new page for Desmos, because what I want to show you then is that we wrap up is basically how circles and ellipses are related. So let's say I make a circle. And let's go to a basic circle centered at the origin. X squared plus y squared is equal to 1. Well, let's enlarge this so we can see it a bit better. Okay. Now what I'm going to do is I put some constants, coefficients in front of these. I actually just call these A and B. Those are not the, I want to call it something else. So R and T. So don't confuse with the A and B we had before. Let's do sliders for both of these. Okay. And what I want to show you then is as long as R and T, these numbers in front are the same, we have a circle. But if I make R, as I make R bigger, I get an ellipse, and actually it becomes more narrow that way. Okay. We'll go back to 1. Also, the smaller than 1 makes it wider. Let's go back to 1. Okay. Same thing here. If I enlarge this, I also get an ellipse. Okay. Let's go back to 1. This time let's stop at 2. What I want to show you then is long as the coefficients in front are the same, I get a circle. Okay. So what that means is that a circle is a type of ellipse. Okay. A circle is simply a type of ellipse where the numbers in the front are the same, or if we think about in terms of our equations, where basically A and B are the same. Okay. So in both cases, both ellipses, if you make A and B the same in both equations, here or here, then what you get are circles. Okay, if not, if they're different, you get ellipses, and that's the difference. Okay, let's read what we talked about. So today we've learned how to the basics about circles. Okay, the equations of circles, how to find the equation or find the center and radius. Also, how to find the equation of a circle in a non-standard form. Okay, they learned about ellipses, basically about the general equations of both of those. We learned that if your bigger number, we called a squared, is under your x squared, you have a horizontal, called the horizontal major axis. Okay, the length of the ellipse, the vertices are at the end of this major axis, and the length of the major axis is 2 times a. The minor axis, which goes through the center and it goes from the other ends, is called the minor axis, and it's called length is 2b. Okay, then we're always use focus or foci, have a foci inside each, and basically those equations are given by, all the equations you see are given by these, okay, where the c squared is a squared minus b squared. And those relationships, everything is exactly the same in both, except if your bigger number, your a squared, is under your x squared, you have a horizontal major axis. If your bigger number is under your y squared, you have a vertical major axis. You also learn that you can write any ellipse in this form, okay, where then once you have this form, then you can find all these details of the ellipse. Thank you. Have a good day.